Mehmet Yavuz. I'm the CTO and co-founder here at Celona. And today I will talk about guest access on Celona 5G LANs with neutral host. And here, basically, the main purpose of the guest access is the indoor cellular service. And we all know that indoor cellular service is a big challenge. It's not only basic coverage, but also capacity. Many times we have all been in a situation where inside a building, we hardly get any bars on our smartphones, or even if we do get some bars, the performance, throughput, and so forth may be really bad. And of course, there are multiple solutions that has been tested for a while for this space. One solution is the basic macrocellular deployment. And operators deploy these towers with macro base stations, but this usually takes a long time. In the areas of poor coverage, they need to get site permits and so forth. It's usually very costly. And buildings are getting more and more energy efficient, which also makes the penetration from out to in, from macro base stations outside to inside buildings very challenging. And operators also try to deploy some small cells inside buildings, and that means each operator brings their own equipment and try to deploy these small cells. But that's also very slow, very costly. They need to bring their own backhaul and so forth. A third one is operators doing Wi-Fi calling, and in some places it works. Many places there are challenges about the reliability and quality of service. And the last one is distributed antenna systems, and that's where operators bring their base station equipment to a basement of a building and then distribute the signal indoors, and that's also very costly too. So all of these challenges exist today, and what I will talk about is the so-called neutral host solution that we bring with our Celona 5G LAN, which is essentially adding the ability to utilize public cellular broadcasting from our 5G LAN APs. So the 5G LAN APs can broadcast the network IDs belonging to different operators and securely tunnel that traffic to each operator's core so that the mobile network subscribers belonging to these operators can get service from the 5G LAN network. So as I mentioned, the most common solution today for traditional macro coverage is DAS. And here I'm showing a typical DAS deployment and comparing it with the Celona 5G LAN service. So on the left, you see this distributed antenna system, or so-called DAS, where basically an operator may bring their base station equipment to the basement of a building. And then from there, they will run these fibers to each floor. And each floor, there will be a distribution unit distributing the signal to different remote radio units. Sometimes it's operating a base station, baseband equipment. They may have a donor antenna that just receives the signal outdoors on the roof and then distributes it inside the building. So this solution I'm showing here, as you can see, has lots of different components. There needs to be a dedicated cabling for distribution of the signal. There needs to be dedicated radio units or RRUs inside the building. And the cost really amplifies, right, as you bring all of these things together. And besides, an operator needs to bring their own signal to that building. So that's why you don't see DAS very widely deployed. It may be very high-end enterprises or venues. You may see some DAS deployments, but many places continue to suffer from lack of proper cellular coverage indoors. On the right, I'm basically showing the Celona 5G LAN architecture, which is a much simpler architecture. And of course, first of all, for the 5G LAN, you typically have a private spectrum such as CBRS that's free of charge. And then the simple architecture is such that the APs are integrated with the LAN infrastructure. They are connected directly to the switches that exist inside the building. And the other key benefit is each AP creates additional capacity. On the left, when you see the DAS system, you have basically one AP, baseband equipment, serving to the whole building. On the right, each AP that you deploy creates additional capacity because it's basically self-splitting. And it also is fully, totally integrated with the enterprise infrastructure. It's a very scalable solution, and I'll talk about some more details of this. So how does it come together as a 5G LAN solution? Here I'm showing the end-to-end architecture, but it's usually helpful to imagine a use case, right? For example, imagine you have a venue or a shopping mall where they have deployed 5G LAN for their private use cases. And in this venue, they may have deployed these APs, just like a Wi-Fi AP. And then there may be devices such as IP cameras or point of sales devices or handheld devices belonging to the workforce. They all connect to this network, right? So that's what I show on the top side. And these devices use the SIMs that we provide. Is basically the private 5G offering. But in the same venue, you will have customers and visitors working with their own devices, and they may belong to operators. These devices may have SIMs from T-Mobile, Verizon, or AT&T, whoever. And with neutral host capability, the same network, the same set of APs that is deployed can broadcast the network IDs, or so-called PLMN IDs, of these different mobile operators. So the customers and visitors in that venue, as I show here, can have a highly reliable, high-capacity cellular service in the same network. And the rest of the architecture is the same architecture. We have the Celona Edge, the orchestrator managing this, but the traffic of the mobile network subscribers is tunneled separately to the operator core. So that all happens using the same network architecture that we have as Celona.
I have a question on that slide. The guest access versus the Celona SIMs. Can you set a guarantee that the Celona SIMs have a higher priority than the guest, and set a percentage or something, so you don't waste your Celona infrastructure on just guests wandering in?
What we do is we segment some of the capacity for the private use cases versus the guest users, and we can further segment it for each operator. So we can guarantee certain part of the bandwidth allocated to guests from operator 1, operator 2, and certain fraction reserved for the private network. Of course, if there are no devices from one of those operators, that capacity can be used on top of the reserved capacity for a private network. And one question is, okay, how does it really mean from an end device perspective, right? So here I'm just basically showing that you will have different types of devices in a 5G LAN network, right? On the left side, I'm showing devices that have a so-called private SIM, right? That comes from Celona that we provide to the enterprise or through our channel partners that goes into those devices, either physical SIM or eSIM. And on the right, you see the devices with public SIM, right? This is the regular devices. All you need is the support of the specific band, like CBRS in US, for example, in that device, and the device connects to this network. Now, the interesting piece is you can also have some devices with dual SIMs. And those devices can also be managed by the enterprise, and they can have the private SIM and the operator SIM in the same device, or you can have an MVNO providing these SIMs with dual credentials as well. So all of these models exist, right? All of them can work under the same 5G LAN network. Now, if I take you a little bit deeper into the deployment, because you really want this model to be scalable, right? How do you scale this kind of service? And this is showing our ultimate vision here. So you have one 5G LAN network for both private and neutral host service with a very flexible deployment model. And in this case, the devices from public MNOs can come in and get service from the same network. And each operator can be added to this solution through basically orchestrator, basically a one-click on the orchestrator to enable the service for each operator. And you can have very different business models, right? It can be a large retail client. They may have this service for all of their retail stores, big box stores, or you may have a managed service provider that serves to many enterprises, right? With the distributed sites, multi-tenant facilities, and they can manage all of these things, all of these end deployments through the orchestrator as being one place to provide this service, and they can have the relationship with the operators. So the scalability is something that I really want to highlight, because you don't want, our vision is this not as a service for the top 1% of the indoor commercial real estate, right? It's really a very scalable model. Even small locations, branch offices, and so forth can be enabled with this neutral service through the centralized orchestrator to manage all of these. Now, I know most of you folks are very technical, so I just also wanted to show you some of the network architecturing concepts here. So here, you're basically seeing the architecture from the end device to the end service that is provided by the operators and the private network, right? And what really happens here is on each AP, you essentially have different IPsec tunnels going. So the first one you see here as green is the so-called S1 connection from the AP to the Celona edge. And this connectivity carries all the traffic associated with the private network. From the same AP, you will have a different IPsec tunnel going to a so-called Microgateway, MOCN, which stands for Multi-Operator Core Network Gateway. And this IPsec tunnel is terminated in this gateway, and then separate IPsec tunnels are established with each operator. So this way, the traffic belonging to the private network and the public network is already segmented at the AP itself. And then you have end-to-end encryption from the AP to the Microgateway and from Microgateway to each operator core. And the Microgateway typically would operate in a DMZ type environment, a secure location. And that way, there is no security concerns or issues associated with the traffic, being in the enterprise network and so forth. The other part, as we discussed a little earlier, was about how do you ensure quality and capacity between these different use cases. And this, as I said, by segmenting the capacity of the APs at a very granular level, right? You can guarantee a certain fraction of the resources allocated to each type of traffic. And the other really nice point is, in places where you need more traffic, you can simply deploy more APs. So it's a very scalable solution in that regard. If you remember what I mentioned about DAS, it's usually one baseband equipment, one AP essentially put in the building, and that capacity is shared everywhere inside the building. Here you can deploy more APs, more 5G LAN APs, wherever you need capacity and performance. I would like to invite you to see a demo of these solutions and go to celona.io/journey. You can see either on-demand demos or pre-recorded demos at that location. And I would also like to invite everyone to join our frequency community. There are a lot of interesting discussions happening in that place by different folks from different parts of the ecosystem. They're all coming together and discussing different specific solutions and use cases. And this is at frequency.celona.io.
Thank you for that, Mehmet. I do have a question. It has to do with the MOCN. Is there some entity that builds those? So you set that up in the DMZ, but then how do you orchestrate that? Sorry, didn't mean to use your word again, the orchestrator. How do you actually do the setup so that all those MNOs are accessible to you? Is there for a fee service? Is it a business model that you work with, or is it something a small business could just do on their own?
Great question. I mean, the first aspect is the MOCN, or the Microgateway, is part of the solution that we offer, right? It's essentially a microservice. I mean, you can think about it as a SDN function that comes with our solution, end-to-end solution, just like the APs and the edge and the orchestrator. MOCN is something that we provide to our partners or end customers. As part of MOCN, there is, aggregation routing type of functions. There's IPsec related functions and establishing those IPsecs with the operator. So we provide all those abilities in the Microgateway. Now, who manages and operates the Microgateway? There are different business models, and we work with our partners. So in some cases, if it is a big customer with hundreds of stores and offices and branches, their IT may operate that Microgateway. In other cases where it is more smaller enterprises and so forth, a managed service provider or channel partner comes in, and they can operate that service, they can provide that service, and they can have a multi-tenanted solution for their end customers. And on the other end, there is the interface to the operators, of course, and I showed it through one click of button in our orchestrator. So we enable that, but that entity operating the Microgateway needs to have the relationship with the operators. And there are different business cases out there. This is still in early phases, to be honest, in terms of the business models. But some operators seems to think that as long as they can extend their coverage indoors, it's a great benefit to them. And they care about KPIs and quality and so forth. Of course, all of those SLAs need to be maintained. But it's very exciting, honestly. We'll see in the coming years how it exactly will evolve. What we are really seeing is lots of trials and so forth happening this year, and the commercial services starting next year. And I think a few business cases will start initially, and more may come down the road. Sorry, a little bit long answer, but I hope it answered.
Oh, no. Yeah, another question was, on one of your first slides, you have the word COTS, hardware, and I'm not familiar with that.
Yeah, it is COTS hardware. So essentially highlighting the fact that our solution is really cloud native microservice kind of solution, right? So it can run on different environments, both our edge and also the Microgateway. So it's a software-defined network solution, and it can run on like an x86 commercial off-the-shelf hardware.
Well, speaking of acronyms that I wasn't familiar with, previous slide you had MVNO when you're speaking about multi-SIM on a single device. Can you fill that story out a little bit for me? Yeah, right there on the bottom. Would love to know more about that. Yeah, so it is an extension of the mobile network operators, right? MNOs are like AT&T, Verizon, and no more Sprint, actually T-Mobile and so forth. The MVNOs are the ones which do virtual service, right? They may not have the infrastructure. So MVNO stands for Mobile Virtual Network Operator.
And these companies usually have some relationship with an operator or multiple operators. And they provide service to end customers like Cricket, or there are some examples out there. Without owning actual infrastructure, they provide SIM cards or SIMs in general to the end devices, and they sometimes have business relationships with multiple operators, multiple MNOs globally. So in some use cases, you can be a subscriber to an MVNO, and your device can work in US, in Europe, globally. And in each place that you go to, in each country, the MVNO, the virtual network operator, will have business relationships with the actual network operators there. So the point here is they can provide a single SIM card that can get service from these neutral host networks, depending on whichever country you are.
And so I guess this is, I guess I must be, obviously being an American, I guess I have an American-centric view of this. I've never heard of that. Is that something that's common outside of the States, or something I've just been missing my entire life? Or how do people typically buy that?
I mean, even in US, there are MVNO services. I think Cricket is one. Srini, Andrew, help me out here. What other examples of MVNOs in US?
Metro PCS used to be something like that, which got acquired by Sprint and then now with T-Mobile. There are Leap Wireless was one which was there, from the old days, which are there. So if you look at any of the prepaid devices in the market, you would see they're based on MVNO.
Gotcha. Okay, that's what I was missing. Okay, thank you.
And I would add, I think they're usually marketed as bulk budget data plans, where somebody doesn't want to sign up for the more expensive MNO. And I think they come with some quality restrictions. I don't know if restrictions or quality differences in quality compared to the MNO networks directly. Like you may be throttled after a certain amount of data or something like that.
Yeah,
but those are policy-centric byproducts of the relationship, right? Once that's on a Celona network, you can do whatever you want with it.
True. Actually, that's a good point. From the radio access network perspective, yes. But on the core network, all the traffic goes to the operator core, right? If an MVNO has a business relationship with a certain operator, and that mobile network operator has a policy in their core network to throttle the traffic, it's the same mechanism that works here, right? So we will let the operator to decide on the priority. If they set different QoS policies, we will respect that, right? We'll use whatever the operator QoS policies are within the reserved segment for that operator.
So you wouldn't necessarily authenticate their SIM and then bring terminate their traffic on your gear. If you authenticate somebody an MVNO SIM, you are implicitly then going to turn around and tunnel that back to that MVNO operator.
Yeah, actually, we don't even authenticate it, right? When a device walks in, let's say a device with the MVNO SIM walks in, that will the device first will detect the operator network ID, right? And it will attach to the AP, and we will basically all the traffic will be tunneled back to the operator core, and the operator will authenticate that SIM and allow the service, because it's, again, as I was showing, it's a separate pipe, right? That's happening here. So the whole thing goes to the operator core, and there they will have that relationship with the specific MVNO, and they will authenticate that specific mobile device with the access policies and so forth associated with that business relationship they have. But the nice thing is we don't need to go into all of that, right? It's all taken care of. It's all transparent.
Well, and I guess that was where I was going to come from, right? As from a Wi-Fi perspective, none of that ever happened, right? You authenticate at the radio, and so that's my own ignorance showing through there. So, okay, thank you for filling in
can you talk a little bit about the handover algorithms? Because here in the cellular world, you've very much planned the handover, right? Overlapping coverage and all of that. Here, the overlapping coverage isn't planned at all. And it's not really like a roaming agreement between countries. So have you had to tweak the handover algorithms or do something special with that?
No, actually, this is a great question, and the nice thing here is it's all 3GPP technology, right?
Right.
And we use the same handover mechanism that operators use. So what happens is if a device walks into let's say a device is outside in the macro coverage, right? And the device walks inside a building, and what will happen is the device will detect this 5G LAN AP and basically send a measurement report to the macro network, macro base station. And then everything goes back to the operator core, and operator will trigger a handover event from one base station to another base station. From their perspective, it's just a regular mobility event, handover event from one base station to another base station. Now, the other interesting aspect here is we are on a different frequency, right? This is a different frequency channel. It's not the licensed channel operator macro network is working on. This is a private spectrum, such as CBRS. So there is no interference issues between this private 5G LAN network and the licensed band operator network. It's just a different frequency band, and the devices always search for different bands to get the target, so-called target base stations, target cells. So the only thing that needs to be done is this frequency band needs to be put into the device as one of the bands the device should be searching for at any given time. And the handout from the 5G LAN to the macro network is a very similar thing. So it's just standard 3GPP handover we do.
And that control you said is in the service provider's network. Correct. But once they've transitioned into, let's say it's a retail business, as you mentioned, once I'm moving between those cells, that handover is handled within the control of what's within the retail business, or does that also go back to the cellular operator to manage that handover?
So the traffic is always anchored in the operator core.
Oh, okay, great.
Right?
Okay.
It's always anchored there. But as the device goes from one AP to another AP, this IPsec tunnel that you see is switched, right? From one AP to another AP. But it's always the same Microgateway and the operator core anchoring that traffic.
Yeah, but the handover decision itself is made in the operator's network, not in the local network.
Yeah, it all goes back to the operator. The measurement reports go back to this is like at the radio layer, right?
Right.
Mobile measures the cell signal strength and so forth, and does the handover. So all of that stuff is happening locally, but the anchor is always at the operator core.